Hi, everybody. Welcome to our session. I hope everyone can hear me loud and clear. We're getting underway just on the dot of 5. This is going to be a very quick session. We're only going to cover the very basic parts, but hopefully by the end of it, you'll be ready to explore more with the topic. Okay, so let me just get everything sorted out here. I say, do let me know by chat if you can't hear me or there's any problem with that. Okay, let's go ahead with that. Let me start sharing my screen again. Okay, it's just a quick little bit about the assembly. We're a smart lab that's based out of In5, which is the startup incubator program for Dubai Internet City since 2014. We've done almost 300 free workshops. So apart from the workshop we're doing today, we do one workshop every Saturday, showing people how to work with different elements of technology and especially exponential technology. So all the new gadgets, the new things that are the new systems that you have to find out about. So we try to work hands-on with that. So our categories are split into three. We have hack workshops, code workshops, and data science workshops. Hack workshops relate to IoT and hardware. So whether you're working with embedded systems in Raspberry Pi or the Arduino or different things like that, we try to experiment with hardware. And when you attend these workshops, when they are live, currently they're all virtual, of course, but when you attend them when they're live, we provide all the hardware so you don't need to bring your own. Assembly code workshops are like today's workshops where we work with APIs, frameworks, and apps, and we show you how to do things with them. There's no separate hardware involved. Obviously, you still need your laptop. And of course, data science relates more to machine learning and artificial intelligence. So these are topics that are very, that are very hot right now. And that's why we include them as a separate category. This month, sorry, not this month, the next month in March, we will be focusing on a lot of AI and ML topics. So please do check back on our site and you'll find a lot more information about the workshops we're doing in March related to AI and ML primarily. Our audience ranges from students to professionals to entrepreneurs. Obviously, we are in an entrepreneurship hub, so it's very linked to that. And of course, IoT is also a big topic that does come into, like, if you're a hardware entrepreneur or a software entrepreneur, working with smart devices becomes quite common now as well. Of course, we have no restrictions for students or professionals. Anyone who's interested in technology is welcome to join us. We focus on practical applications as well, as you'll see today also. Do take note of our forum, members.theassembly.ae. That's where we coordinate all our RSVPs as well as share post-workshop information. And we've also built up a community there where you can communicate with each other, centered around exponential technology and Dubai in particular. Our social media handles are Make Smart Things. So you can find us there on Facebook, Instagram, LinkedIn, what have you, Twitter, and as well, of course, on YouTube. We are streaming this also live elsewhere, so you can definitely catch up with the recording also afterwards. We will make a few edits, so it will take a bit of time. So that's about the assembly. Okay, let's get straight into our checklist first. We have sent this out to most of you attending the session before, and I hope if you are planning to follow along hands-on, of course, you can just purely watch and see how you can get along with that. If you are watching the workshop, if you are following on hands-on and trying to code with us, then there are some things you need. The first, of course, is Java itself. You need the Java development kit, the JDK. And we've sent out these links before, so I hope you've already got that. But in case you haven't, this is a big download, so it's about 100 to 200 MB, so it would take some time, which is why we sent it before. You need the JDK, and most of you, if you are Java developers, you already would have that. Apart from the Java development kit, you also need the Thingworx Java SDK, which has to be installed on your machine. By install, I don't mean there's no process as such. You just download, just take the zip, and I'll show you a little bit later on how you can, if you've not got that, how you can configure that. So you need the Java SDK from the PTC marketplace. It's a free download. You have to go to the marketplace and you do have to sign in using the same account you've used for your PTC developer thing, and you will definitely get that. I will show that to you a little bit later on. You should have a Java IDE. If you're a Java developer, of course, you already have that. I'm going to use Eclipse, and Eclipse is there. It's another big download, so I hope you've already done that. But you can also use Android Studio and Gradle and different tools that you have, so it's definitely worth thing there. I'm going to also So this is important. There are some additional samples which we will use at the end of the workshop, not at the end of the workshop, in the latter half, rather. I'm just going to share it to you. Let me just make sure I can share with chat. I'm just going to get a few, I have the link. So in case you can't access from there, I'm just trying to find it for you. First of all, this is the link if you want the SDK, and I'll show you how to browse to that also. See the chat. So that's the link for the SDK in case you haven't got that. That's a short download. So if you haven't done that, that's fine. You can get it now quite quickly. And the other samples that I want to send you. So this is the Okay, and if you look at chat, so I've sent you two links now. One is, of course, the first one are the additional samples. They're jar files that well, they're not just jar files, they're also things. So just download the zip that's there, the Java SDK extra samples.zip. We're going to use that for the file transfer example we get to at the end. The other is actually like there's a tutorial, of course. Thingworx has a very extensive support system there, and there is a nice tutorial which works with those samples, and you can get that also. We won't cover all of the details in that, but we will cover some elements, but you can just keep that in handy. Okay, so coming back to our checklist. So assuming everyone has downloaded that, let's get straight into it. Okay, I am going to give you a little bit of the theory behind the subject before we dive right into like going hands-on with that. So I've shared this slide before in previous workshops, but it's a very important one. The question is, what is the edge? I mean, a lot of you are familiar with IoT, but the edge is a term that's used very extensively in IoT, and it's important to understand it visually also. So when we see here, before we start with the edge, let's think about the cloud. Now, the cloud is actually your Thingworx server. And of course, it could be on the cloud. It could be on a remote location. In our case, we will be using Thingworx own PTC cloud to do that. Now, the Thingworx server, what you see here, if you can see my mouse, this is the platform. This is a regular server, a web server that's running. It connects to a database where it stores information and exchanges information. And then it also makes available applications that can be accessed from clients. So either in your browser or through an app, you could be running with, you would be viewing the information on the cloud from there. But the other side of the equation is the edge, which it could be far away. These are the smart devices. So things like your Fitbits or any like your Raspberry Pi that you've set up at a remote location to maybe connect it to a security camera or connect it to sensors that are checking your temperature. It could be they are actually live in the field, and they are collecting data that has to be sent over to the cloud, and it's synced. So you could just think about the edge consisting of devices that collect data in the field. And if you look at this example that's shown in the diagram, they could be connected through a gateway. So they could be multiple edge devices with multiple sensors, and they all connect to one gateway that sits on the edge side and that communicates with the cloud through a variety of protocols. Now, there could be a firewall in between here, and the beauty of solutions like Thingworx is that they can pierce the firewalls, they can work with different network topologies, and you don't have to think about it. Because obviously, though we're just talking about devices connecting to the internet, is different from humans connecting to the internet, where security is handled through a number of ways, and it's a fairly low risk environment. When you have a device that's connecting directly to the internet, you do need to think about security. You do need to think about a lot of things. So that's why it's important. In our scenario, we don't have a gateway. We're just going to directly be connecting from the edge to the cloud. So just have a think about that. Okay, so connecting from the edge to the cloud, there are a few different methods that we have. And we've used, in previous workshops, we've covered all of those except the edge SDKs. We've done the REST API, which is just using HTTP web service. So HTTP requests, these are one way, obviously, and you're able to request, just writing simple code using Postman or something. You can write code that extracts things from the cloud, as well as you could update properties. It's very powerful. You can do a lot, but it's only one way. So you can only go from the edge to there. The cloud itself cannot push things to the edge. using this REST API. And of course, it also requires code. You can use Postman to test it out, but usually you write code to do HTTP requests. Before we go to the Edge SDKs, look at the Edge agents. We've done that in a previous workshop also in the prep for our analytics server. Now, this uses the AlwaysOn protocol, just like the Edge SDKs do, and we're going to talk a little bit more about that. But this is a two-way bi-directional protocol where the cloud can also communicate with the edge device. You can push things onto the edge and you can send things securely doing that, as well as communicate on there. And edge agents that, like we've used before, are ready-made software like the Thingworx, edge microserver. We've used that. So if you're just looking at a very basic implementation, those are quite handy, but sometimes you need a bit more, and that's where the SDKs come in. And if you're more comfortable as a programmer, whether it's in C, Java, JavaScript, Android, iOS, those are all the different SDKs that we have. We'll be focusing on Java, but this requires code, and that's where you have to. So coming through about AlwaysOn, we mentioned AlwaysOn a lot. AlwaysOn is a proprietary Thingworx protocol that is built on top of WebSockets. Now, some of you might be familiar with WebSockets. If you look at the diagram, I've taken that from a service called PubNub, which also uses WebSockets. And WebSockets are very useful. We've done many workshops in the past where we worked with Raspberry Pis and we've used WebSockets. WebSockets, the simplest explanation, it's an upgrade to HTTP. Now, HTTP, of course, we know has several limitations, and WebSockets upgrade HTTP so you can create persistent bi-directional TCP connections. Obviously, TCP is the transport layer there. Persistent and bi-directional, like I said, the server can communicate with the client can communicate with the server, and the connection is maintained for as long as we need it. The channel is maintained, so it is a dedicated connection, and that's very useful for IoT and probably needed. It does also work with cross-origin and cross-platform. Cross-origin, of course, has its own security ramifications, but we usually compensate for that with other methods. There's very low overhead. We try to keep low latency. It does get through the firewall as well. That's important. So if you have a firewall, it doesn't just drop it on there. The protocol, so like you have HTTP:// when you type a browser, WebSocket starts with WS:// and we'll see that later on. If we're using a secure one, which is corresponding to an HTTPS server, we have WSS, WebSocket Secure. So that's very important also. So let's have a look at, okay, you can see that the WebSockets take care of a lot of things, but we do need the Java SDK on top of this to enable our program. So let's have a quick think about what's the primary purpose of the Thingworx Java SDK. So, and you'll see this in the documentation as well, which we'll look at a bit later too. The Java SDK establishes and manages a secure, always-on connection with a Thingworx platform. So the Thingworx platform is a server, it could be on the cloud, and the Java SDK is working on the edge device so that it continues to maintain this connection where it can communicate back and forth. So we have to think about two programmatic interactions there. So one is, of course, for properties and services and events that are already on the platform, the event entities. So there's simple programmatic interaction for the edge device with those. And there are also the reverse case where you can define properties and services that can be accessed from the Thingworx platform that will be, so these are properties and services with things that are on the edge that are being accessed from the platform. So like we said, bi-directional communication. I have another diagram that will show you a little bit more about that. A few more details about the features. I just want to talk about the most important thing with IoT, and this can't be stated enough, is of course security. So they maintain secure, persistent connections. It uses OpenSSL by default. It rejects self-signed certificates. So if you have a certificate like you have with secure websites, that is the default mode. We will disable them because we're going to just practice with it. So we're not working in a highly secure environment for that. There is service, there is certificate validation, verification on both the client and the server. And of course, there's SSL and TLS validation. And another thing to remember is this can work through proxies also. You can configure it to work in a proxy. So if your edge device is behind a proxy, it is possible to do that. Compression is an important one because we talked about low latency. So we do want to make sure that the amount of data that's going back and forth. Remember, these devices could be multiplied many-fold, and that's why we want to make sure that the data that's being sent back and forth is compressed at both ends. So the Thingworx Java SDK uses the Netty library, and you'll see that a lot in the console once we actually work for that. It works at the edge for all WebSocket communications, including file transfer and tunneling. So it does compress as we speak on there. Speaking of file transfer is another big feature. We will be showing you how you can do file transfer. It's bi-directional, so you can send files from the server to the cloud, to the edge, or from the edge to the server. We'll show you both. Tunneling is an interesting case, and tunneling is very useful when you want to create a secure firewall transparent application tunnel for TCP-based apps. So you could use something like SSH or VNC to connect directly to your edge device, even if it is on a local area network, and usually you'd need to do some port forwarding service, but it's all built in with the Java SDK. So it builds a tunnel, and in fact, the Thingworx, and we won't cover that in this session, but Thingworx mashup can be built in such a way that you could actually view the desktop on your edge device, or you could control the edge device as you wish with that. So tunneling is a very important one. We're going to just talk about it now. We won't show you too many subscriptions because that might be enough to cover for a different, and I'll give you an example also later on. Coming back to our things, of course, it covers property service subscriptions and service execution. So properties that change on the edge can trigger events that can be subscribed to. So anytime a property changes, an event can be triggered, and you can do different things on the platform to handle that. You can execute services that are defined on the edge from the cloud. That's a big bonus from there, and that helps us a lot with different things. The final point is more about, like, say, maintenance, connection monitoring, and duty cycle regulation. So you can manage how the connection stays stable. So you don't have to, unlike HTTP, which is stateless. In this case, the connection, as we said, is maintained. So you do want to monitor the connection throughout, but you also want to see the duty cycle so that you don't have too much idle time. You don't have, where you can just properly have that. Okay, so coming back to, this is a very important concept. And if you saw the preview, you would have seen this diagram of remote and virtual things. So if there's one definition that you really want to memorize throughout, it's the difference between remote and virtual things. Let's start first with thing. Obviously, if you've done this workshop, you know that things are at the center of Thingworx. So things are our data models. So the data models on the cloud that model real world assets. It's basically a collection of properties, services, and events. And sorry, just give me 1 second. Actually, just before we do that, I'm just going to come back. I forgot one thing on this. So there are a few things that are missing in the Java SDK that are there in the other SDKs. So there's in the C and the .NET SDK. And I just wanted to mention that because in case you see that and wonder why it's not in the Java SDK. There's no offline operation mode in the Java SDK, but it's there in the C and .NET SDK. And that's very useful, obviously, when you want to work on devices that don't have continuous connection. There's also software content management support. So you can work on creating, managing, and testing and deploying your packages directly using that. That's not available in Java SDK, but we'll cover that probably in a later session. Sorry, coming back to remote versus virtual things, I'm just going to start again because I kind of went back there. So remote and virtual things, a thing, as we know, is a collection of properties, services, and events. And this usually is a model that is built, a data model that's built on the cloud platform to represent our real world object. So it could represent our edge device, for example. So it would contain all the properties and all the data would be sent and stored in the cloud platform here. So for example, if you talk about a Raspberry Pi that has a temperature sensor attached to it, the temperature value would be stored in the cloud platform as a thing. Now, what you want to think about is the distinction between two types of thing, remote thing and virtual thing. A remote thing, like a normal thing that we worked with, is built on the cloud and it models a remote asset. That's why it's called a remote thing. So a remote thing models a connected asset and is created in Thingworx Composer. It derives, remember we told you all things have to derive from a template. So a remote thing has to derive from, rather than a generic thing, it has to derive from a remote thing template or one of its derivation. So there's remote thing with file transfer, remote thing with tunneling. There are a few different options and we can do that. So the remote thing, remember, exists on the cloud. So just keep that in mind. A virtual thing is created programmatically with the Edge SDK on the edge. So we have the virtual thing and the remote thing, and these are basically mirrors of each other. They have to have the same name as well. So when you're creating a virtual thing in code, that has to have the same name as your remote thing on the cloud. These things can be bound so that in the thing, so that they have maintained an always on connection that continuously updates. So it represents the remote thing on the edge, so you would have properties. So you have to create it programmatically with the edge SDK and then sync it up with the remote thing. And we'll see how we do that directly there. So the binding process, and this is just to keep in mind, this we'll be walking through completely when we actually show you what's there. We have to our first step is in Java to create a class that extends the virtual thing. So this creates the virtual thing. The virtual thing is a built-in class in the SDK, and we use this to just build up to extend the virtual thing, and then we add our own properties, our own services, our own events to the class. So this will represent our virtual thing on the edge. So it could be a Raspberry Pi edge device or any device that has that. In the main code, then we create the client configurator. Now the client configurator provides parameters. So it's the configuration essentially for the communication with the platform over WebSocket. So that's where you set the address of the server. It's where you set the security claims, which you could be doing by authentication, or in the way we're going to use it through an application key. After that, we create an instance of the connected thing client. So the connected thing client is a class that facilitates communications to the platform. Remember, all of this is being done in code on the edge. Yeah. So the connected thing client takes the client configurator as its configuration. Then we create an instance of the virtual thing, which we have extended, and we execute the connected thing client bind thing method. Now the bind thing method, and we pass the virtual thing to that. We pass the virtual thing instance. So it gets a list of all the different things. We don't have to do it just once. We can do it for a whole list of items. And then we hit the start method. After that, all the bound things will have a bi-directional connection with the, with the remote thing that we have on the cloud. But after we write the start, where we invoke the start method, we can write custom code that updates periodically. So there are things like scan rates, scan requests. We put that all there. So there are long running processes. So sometimes you need loops for that. And finally, when we're done with all that, we call shutdown on that. Okay, so that's about it for the, for the part here. I'm just going to come back and share my whole screen now, because I think right now you can probably only see my screen, but we're going to get hands-on with things. I just have a few more links that I want to share with you, and I'm just going to put those in if you have any concerns about that. Actually, no, I've already shared that, so that's fine. I'm just going to come back to my share. I'm just stopping share for a quick second, and I'm going to share my full screen so that you can see my windows there. Okay. So we're done with this. I hope everyone can see everything on my screen. Right? We've got that. Okay. So the first thing we want to do is we want to open up, by the way, before I get started, let me just introduce you to Total Commander. This is something that I use. It's similar to Windows Explorer. It's something that's age old. If you're familiar with Norton Commander back in the day, it's just a it's just a double screen, double tab view of my file explorer. So each side has an explorer. So the left pane has an explorer and the right pane has an explorer. And I just use this because this is very quick to do that. But anything you do here, you can do in Windows Explorer or in any of the file management thing. So the first thing that I want to do is I'm going to go to my command window from here. Right. I want to make sure that my JDK is installed. So let's just it's just java-version. Right. Oh, sorry. I put a space. Sorry. There. Yeah, so it tells me that the Java version I've got is 15.02. For using the JDK, you need to have at least 1.8 SE as your Java version. So make sure it's at least 1.8 SE. That is the version that is optimized for that. Now, I'll just quickly show you also actually how, in case you haven't downloaded the Java SDK from the marketplace, I've got a window open. Okay, I've done it as an incognito because I'm already logged in as developer there. But this is what you should see if you come to the marketplace. So you'll have to log in there with your system. And then what you need to do is you need to go, I've shared the link directly, but if you want to go, so there are a bunch of goodies that you can use to extend your Thingworx experience here, but I'm going to go directly to the SDKs. All the SDKs are available here. And you can go there to Java SDK, obviously, and you have the other ones also there. My account's already there. Let me just make sure I'm logged in. Oh, I'm logged out. Okay. Let me just log back in so that I can, because normally you would see a download button there. Okay. I'm just going to click on download now. And I'm just going to log in. So if you haven't done this already, make sure you can do it now. This is not a very big download, so you can do it quite quickly. So it does give you a purchase window, but it's just a $0 thing. So there's no money exchanging hands. It's a free download. You just hit continue. The reason I'm using this account is so that because I had already downloaded it previously. Oh, I have to agree to the terms. And I just place order. And once you do that and you go to My Apps, it'll automatically add it and you can download. So there's some of the things I installed previously, which I've got from there, but I want the Java SDK. So once I click on that and it starts downloading, I'm not going to actually download the whole thing because I've already downloaded in the past, but you can see it's not too big. It's just about 12 MB. So coming back here, I've already got it installed, as I mentioned. I've got a whole set of downloads. So you just take the Java SDK, right? And you can just unzip it to a different folder. And then you can just copy. I'm just going to copy it to a different workspace so that you can get an idea about what it looks like. Let me just cancel this so that I don't need to get it a second time. Once you've done that, you have the folder. It's still copying. So once you do that, just copy it to any folder on your edge device. In this case, my edge device is going to be my laptop. And then you can go with it. So it has the documentation under that. So you can see the developer's guide. A lot of what we're covering today is mentioned there. And you can see a whole bunch of different things there. There's a PDF version and oh, it's opening up. So you can have a look at the details in the documents there. And it's quite extensive. So you'll get everything that, even we'll walk through on the samples, as well as a bit of data there. So you can just look that up. Apart from that, what we also have is, this is an important one. So you need to keep track of, so this example import. So we're going to look at the samples that are built in directly. So they're under samples here. And we'll come back to that later. Lib is which contains the actual jar files that we will need. So you can see all of these are available. The main ones that are there that I will be doing a lot of the work are Thingworx-common-development and Thingworx-communications-client. And this one is the Java doc, which gives you all the details. But you need to install all of those. We'll just get into showing you how to do that. The first step that you need to do is the entities, by the way, contain in XML things that you need to import through Composer. I'll show you that also in a bit. And samples actually contain the files that we're doing there. The resources are there with the main things. The main code files are all here. So there are 3 examples. There's simple thing in Steam, which contain Java files. And we'll be importing that later. So anyhow, so this is what we've got. Now, the first thing you need to do is you need to open up Eclipse, if you're using Eclipse or whatever you're doing. So I'm going to take up Eclipse. I already have 2 projects there that are open, but I'm going to just for the sake of the session, I'm going to create a new project. So I'm going to create, oops. So from here, we just call it something, let's just say Java SDK, or let's say TW SDK test, right? Call it anything, it doesn't matter. Like I said, you should mention the execution environment should be at least version 1.8. I've got 15, which is the latest one. That's also fine. It will be backward compatible. And you just say next, and it will create it in the default version you've all got there. You don't need to check all these other things. These are all default. You can just use the default ones. Just say finish. It'll ask you for a module name. You don't need that, so don't create it. And now if I expand here, I've got my project file. I've got nothing in it. My source directory is empty. And if I go back to, it actually creates it in my Eclipse workspace. So you can see that I've got TWSDK test and all my files are there. So I'm going to come back to that later on. Anyhow, the first thing that we want to do here is we want to set up our user library. So we go here, we right click and we go to build path, right? And we go to add libraries. Okay, so under library, I need to select user library. So I had previously already got the Java SDK, but I'm going to create a copy. You can do that. I'm going to actually go to user libraries and not use it. So I'm going to create a new one, which I'm going to call TWSDK, right? Now under TWSDK, what you do is you have to go to, sorry, just a second. So for TWSDK, make sure you select that. You go to add external jars. And then you go to your lib directory. So this was under downloads. I had it, wherever you've got it stored. This is the original file. So you just go to the lib directory and you just select all the jar files there. So from Commons Codec, there are quite a few. So just make sure you select all of them and just say, okay. And now this will add it here for, it's added it to your library setting here, but you still want to do the what's it called, the Java doc for the two main libraries. So just scroll down to where you've got Thingworx common, and you go to the Java doc and you can just edit that. You can just take the Java doc from an external file. The Java doc, like is the documentation. So it's useful when you're working with your IDE. The last one, if you see, has got the Java doc jar. So you just add that and say, okay. And similarly for, sorry, not for this one, for your communications client Java doc, you need to add that same way, Java doc in archive, and you point it to the same file, right? So this should set up your libraries. So you do apply and close, and then you say finish. Once you do that, you can see TWSDK added. So it's got all the directories that all the libraries that we need, and then all the clients are available there. Okay. Now, the next thing we want to do is we want to import our source samples. So Thingworx, if you look at the samples, like I said, it comes with built-in samples under there. So there are source files that you can use, and we'll only be looking at that. We won't code anything new of our own. We'll just be using this. So we need to get these files into our source there. So how do we do that? We come back to source. Sorry, we come back to project, and we go to import. Right? We want to import from file system. So select file system. Right? So, and then we browse to the directory we want to go get it from. So it's in the same, like I said, you have to go to samples and you go to source here and you select the folder. Make sure it's checked on. And we don't want it to go into the root directory. So make sure you browse and you select the source directory. So everything will be added under source. So once we do this and we hit finish, you'll see that it's added a few things. Sorry, I'm just going to check on chat because I think a few people, okay, no chat messages. So it has added a few examples here that you can see of Java files. Now we're going to look at this. But before we do this, let's go back and let's get to our Thingworx server. In fact, I'm going to come back to this. So we're going to use the trial server that's built in, and I'm just going to make sure it's still connected. I had actually already launched it before, with Thingworx Composer. So if you have created your Thingworx developer portal, you would have automatically got this. This is there. It's under a free trial. I'm just going to show you where it is in case you haven't. We've used this extensively in the past. So if you've come for any of our previous sessions, you just have to access the free 30-day hosted trial, and it gives you a server on their cloud. So you don't need to install anything or do anything with that. Okay, so coming back to our session, my server is already launched, but when it's not launched, you would see something, it would say start server. You should start the server, and then you should note the username first, the administrator, and copy the password for that. I've got it saved in my settings, so I'm already good. So I had actually opened it up already. Okay, so I logged me out from here, so I can just sign in here. I just need to take administrate, and the password is the same that's copied for there. Now, if you look at the, this is important. Each person, like I'll have a different entry for here, and you'd have a different entry for here. So make sure that like that you keep that handy, and I'll explain to you how that works. So coming back to this, and most of you are familiar with this already, I hope. But in case you're not, there is a walkthrough also that I'm going to just actually copy and paste that. Where did I have it? Okay, I'll post that later. You can see the details there. There is a developer .thingworx.com, and I'll post that later for you to check it out. So you can go to you can see the details about the data model, but we've used this enough times. Now, everything here right now is just all the built-in stuff. So this is where all the data models that we're going to be used contain. So like I said, things are important. So our projects, so this is how it's classified, and you can browse everything through this. We've used this many times, so I'm not going to. Now, the first thing we want to do is we want to import the items that we're going to use with the samples. So I'm going to click items here. This is all, everything can stay here. I go to browse. Now, what I want to do is remember the SDK itself, there was a directory called entities. So just click entities, and it's got something called example export.xml. This contains all the items, the things that we need, and you'll see what they look like. So when I say import, okay, did it really fast. So it's imported some items here. So you can see example thing one, simple thing one, first floor steam sensor, tunnel thing, second floor steam sensor, and third floor steam sensor. So these are items that are directly created on here. So if we open up, let's say example thing one, which we'll be using, there are no properties and alerts defined. Well, there is one property and alert, which is current location. It's just a simple location type, and we will be using that. It's got no services defined, but it's got generic services and services that are derived. Sorry, it's a little bit slow there. So these are all built-in services that anything has. It's important to look at. So remember that normally you would have, this is a remote thing, right? So normally we've been working with things, we've used generic thing as a template, right? We're still using generic things. Some of the other things later on, which we're going to be using, don't use generic thing as a template. So example thing is just a generic object. It's not a remote thing. It doesn't get bound to a virtual thing. So the base thing template here is just generic thing. Okay, and that's important. You'll see why later. So I'm just going to cancel this. We don't need to edit it further. So you've got all the details on there. Now let's go back. Let's first try to see. So if you look at my connection here, and the other important section that you have to look at here is monitoring. So you've got remote things here, and you can get all the details. So remember, I told you that first, okay, generic thing doesn't show up here because, sorry, generic, our example thing doesn't show up here because it's not a remote thing. This only lists those which have remote things. But some of the others are like, first floor steam sensor, but it shows that they're not bound. So the connection. So remote things monitoring is how we are able to tell on that. Okay, coming back to our sample. So let's go back to our thing. Okay, sorry, before we do something, there are a few built-in things that we can also use that we're going to use. So there is one particular built-in thing, and I'll actually show it to you from there. It's called the system repository. We've again used this in the past. Now the system repository stores all the files that are involved, and each user can use different directories and all that. So the system repository gives you a few different things. Now, if you just go, it's got a few built-in properties and services that are there. So we're going to go to the service get file listing with links, right? So this will tell you all the files that have been uploaded. Right now, this should show you nothing, right? So if I run the service, it's empty. There's no data, there's nothing there. But our aim, first of all, is going to be to send a file over here from the edge. And this is where it will be stored online. So just remember that. There are different services to interact. There are a few functions. We're going to come back to that. Okay, so now coming back to our code. Let's have a look first at our simple client. So you can go to the simple client function here. Now the simple client function just does a standard connection. We're not going to do binding or anything here. Remember, as I explained to you, The first thing that we need to do in our main template, by the way, it mentions the thing name that we're going to use, example thing one. So it's just given it as a static variable. So we're going to be using, so wherever thing name is referred to, it's actually referring to example thing one. So just remember that. Now, the client configurator here goes and puts in details. So that's where we specify. So config, we have to set the URI. Now, if you see the thing, the URI, it's talking about WebSocket secure, and the port is 443 for secure. Now, if you go back to our services, we need to get this. The WebSockets operate at the same ID that we have. So we just need to copy this. In fact, I'm going to copy it, and let me just save it in a separate file somewhere. Right? So you need to copy this, and that is what goes into, you'll replace localhost with that, okay? It's the same port because it's an HTTPS, as you can see. So we would still have that, and then it has /Thingworx/WS. So slight change from when we were requesting. Now, the second thing that we need is an app key. An app key is what authenticates you. And for that, we go back to Composer. If you want to create a new app key, all you have to do is just come here and say application key. Now, an application key, I'm going to give it, say TWSDK application. An application key is always associated with the username, and we've seen this before. This is a bad practice if you were doing this in production, but it's okay to do it here. I'm just going to go and link it to administrator, and it'll give you a warning because it isn't a good practice to do. You don't want to, because this pretty much gives you open access to any item there. Normally, you want to be more granular with your items there. So we do this once we say save, and the project also, we can keep that PTC default project. Once we do this, it creates a key ID that wasn't populated there. There is an expiration date. By default, it'll be tomorrow, so 1st March. So within 1 day, it is going to make this key inactive. I need to copy this key, and I'm going to keep it in the same place as I did before, and I'm going to replace this in the code. Right? So I've got my app key, and you should also set ignore SSL errors. This tells us that even though, because we don't really have a certificate attached to our HTTPS, so it's fine there. Once we do this, let's have a look at the code before we actually run it. So the first thing it does is simple client. It just creates an object of simple client. Simple client is just a built-in thing in just a default client. It's not to match the same name. You can see simple client is just created there without any different items there. So we've created that in the constructor. All it has is a constructor that just calls the super, which is the base class, right? And it just, because it extends connected thing client, it's just passed the config. So when you create simple client, it just passes config to the and instead of using connected thing client, we're just using simple client here. So we're using, this is in effect our connected thing client. We're passing the config, we're clicking start, then we're waiting to see if, until it's connected. So this makes it asynchronous. So until the connection is reached, there's a timeout there. It does this, and then it'll start reading properties from the thing name. Now, remember again, this is a remote thing. It's not been, this is not a remote thing, rather. It's not been bound. It's just a generic thing, which we're talking about, example client _1. And like I said, thing name just substitutes for that. So it just reads the property from that. And then it gets the value of the thing name. It'll be the same in this case, example client 1, but in case it was different, it would get the thing. You can also do a few different things there, and I'll explain the code more once we actually look at that. Okay, so now that we've done all of this, let's run the code, right? So you just go to code, right click on it, and since it's a Java thing, just run it as a Java application. So you can see it's actually connecting there and then exits. It does a bit of stuff. If we had done it with, if I had for example, let me just comment out the line. Let me just, let's not set the app key. And we did that. And if I went back and I ran it, it says endpoint reconnection was unsuccessful because I didn't give it any, I didn't authorize it. So I'm just going to redo that. So I'm running it again now. So what are the things that we can expect here? Remember, first I said it gets you the thing name, the name of the thing. It just puts that in, in the console. So you can see Netty also mentioned a lot there because that's there. Let me just actually close all the, let's just start this again. Let's just remove all the terminated ones and let's just start it again. Now let's go back to our thing server there. Now, if we go back to example thing one, we'll see a few things. So if you look at the properties and alerts, it's actually updated the location with a value that we set in code. So what you've got here in our code, we are setting the properties. So we are setting a location primitive with 4236 minus 7106, and we're just writing the property directly. So this is a simple function that we did there. And if you also go back to your system repository and I do get file listing with links again, it's actually uploaded a file. It's created the file and uploaded it called simple.txt, which wasn't there before. And you can just directly download that. So we've successfully uploaded a file from, from our edge to the server using this. So let's just have a quick look at the code again. So like I said, the first step that it did, it just connected, it just got the property, just read the properties. The thing name is just an inbuilt property. This was how you write properties. It does client.write property, and it set the current location to the value that we wanted. And then here, like if you look at this, it creates a value collection. A value collection is just setting the parameters for our service. And then, this is our payload. So we set up a payload of the path that we want to upload over there. We want to upload it to, we want to create a file called simple.txt. And the data that we want to create is just, here is the contents of the file. And the client just invokes a service that creates a text file on the system repository with those parameters. So it creates it, calling it simple.txt, and it puts the contents of the file as here are the contents. So it ran this and it just ran the file and then it directly did that. After doing that, it also read back. It invoked a service that gets the file info and it got the value. So it said the file info is, and that will be written into our log. So you can see here in our console, it says the file info is simple.txt. The date is 2021. So we've got all the details directly put in there. So this is how we can do like simple processes here. We've not bound anything yet. We've not bound either there. It also fired an event, and don't worry about this. We're not able to see the event, but we were able to create an event called file event that is triggered to say that the file is created. We've not used that. We've not really accessed that, but you'll see a little bit more about that right now. Now, one interesting thing that you would have seen, now the last bit of the code is where it actually tries to bind thing, but this won't work because we don't have a corresponding remote thing. We have to create it. So this is a virtual thing that's being created called simple1, right? It's just a simple thing. This is the default, this is derived from virtual thing that just exists there. And it's just something called simple thing there. So you can see simplething.java if you want to see the values on there. So it's this is our virtual class, and we want it to bind automatically. So the basic virtual thing, the reason it's not binding right now is because we haven't actually created the item there. So what we have to do is we go here and we create a thing, call it, we have to give it exactly the same name, which is, what was it? Simple1. And under the base thing template, I'm going to I'm going to use remote things with tunnels and file transfer. And that's really it. That's all the 2 things that we need. Once we do this, and because we're shutting down the client instantly after, we're not going to really, let's run the program again. So it'll run and then it'll exit. You just run and exit. And it's done and that. Now we have no way of knowing. Obviously, the connection has been closed as soon as it started. It's just a connection test. But if you go back and you look at simple one and you look at the properties, have a look at the last connection date. So it did connect at 5:51. So you know that it successfully connected. So this means our connection is working fine and we were able to bind. So all that created the always on connection only for a second, it's fine, it's done there. Okay, so now let's get on to more complex examples, right? Like we've seen all the basic things that we can do. We're going to look at the examples under Steam thing that are under Steam. Now, first, remember going back to our process. You can create a Steam thing that is class that derives, that extends virtual thing. Virtual thing, of course, is the built-in version of that. And then you want to define properties that exist on the edge. Now, there are a few different ways you can do that. This way is actually the simplest way. You can do it through annotations. So you can do Thingworx property definitions and you can give it properties here. Like, for example, temperature, pressure, fault status. Remember, we don't have to have created anything on the cloud. We can just create it all on here and then sync it up later on. So we just have a few things. So temperature and pressure are number values, fault status, inlet valve, are Boolean properties. There's something called temperature limit, which I want you to notice when we work with that will do a bit more. That's also a number value, but you'll notice one difference there. The read only is false. Now, read only, when it is false, this means that it can be edited from the server side. So the other properties are read only. So current temperature, I can't edit from my items there, but here I can. And read only is false for temperature fault limit. And we'll show you how we do that later on. It also defines an event. An event is defined on the edge, and I'll show you how this works later on. So this event is invocable, and this one is going to be set off once we work on later. Now let's have a look at the code itself. So it's just defined a few properties that are there. The constructor there is just doing, like, it's just going to the fault fields that we need. It's just using, so this is like, so Steam sensor.fault is a data shape. So a data shape is just a definition of fields that are used there. So it's a definition. Our Steam sensor fault event that we have defined above uses that Steam sensor.fault data shape to define its structure. Okay, so when we send an event has different properties on it. In this case, it only has one thing, which is a message that's given. So the message that is being sent as saying that's the error that's happening is our Steam sensor fault, and this will make sense. After that, we call the super, function initialized from annotations to create the properties. Like I said, you can do it programmatically, or you can just run this function called initialized from annotations. This.init is a function that we've defined here. You can have a look. There's also a few other files like synchronized state, which is more used when you have like long running processes that you want to, sync up the state. So all init does is create this there's a function that we're going to have called Steam sensor readings, and it just defines a data shape for Steam sensor readings. So that is only for that one function. Then we define the services here. So we define get Steam sensor readings, right? And get Steam sensor readings comes from the edge, and all it does is it fills up an info table. And an info table, as you would guess, is just a data. It's a value collection. So value pairs are just set here. So it just sets some dummy values for sensor alpha, and it just feeds it into a table. And we're going to show you later on that how from the cloud you can call this function and just retrieve these values from the edge. right? And there are a few other ones. Process scan request is an important function. You should override process scan request. It's a default function that comes from virtual thing, and you should do it. And you should, all the functions that you want to execute every time the values are being synced up, go in here. So we have scan device. So we do a little check to see if the temperature value is greater than the temperature limit. Right? Remember, the temperature limit is also a property. If the temperature value is greater than the temperature limit, you should trigger a sensor, an error, and then it propagates this event called steam sensor fault, which has the shape, data shape that we've given it, and it gives the event info in that form. So whenever temperature, and I'll show you how this works right now, but it's important to keep in track of that. And again, you set the fault status property to the Boolean variable we have to true based on that. And then it's just done this counter %2 so that it just doesn't try to update it all at the same time, but it sets the different values. Pressure is being set. So this is important. This is all going to happen. Now, these last two lines are very important. If you see it, where it says update subscribe properties and update subscribe events, if I disable this, it would not sync up to the cloud. So all these properties would not. So it does it at a particular range here. And then there are a few additional functions, and that's all that there is to that. So we've seen that. Okay. So now let's come back to, so this is our class for Steam thing. But if you look at our Steam sensor client, that is the main function. This is which has the entry point, the main. This is where we're going to do all our different things. In the previous example, we hard coded the URI and the app key. But what they do is they are actually accepting them as arguments. So what we need to do here is we need to actually define this, and I've got a set here. So I'm going to take the values that I have here. You need to give it arguments. So under run as, you go to run configurations. And under arguments, you have to define in the program arguments. I'm just going to take my values again. Wait, actually, I need to take the full limit, which I've got on my Eclipse. Okay, sorry, I'm just going to come back to that. I'm just going to take it from here. So I'm just going to take this is my WebSocket endpoint. So under configurations, you need to specify it as the arguments. The first argument is our WSS point. The second argument is our application key. So this is a way if you want to keep changing it around. And the third one is actually telling them, like the scan rate. The scan rate is how often we sync up the processor. So we're going to set it to 1,000, which is like 1,000 milliseconds. So every second it would be updating that. The start sensor that we're using is 1. And actually the last two properties we can leave blank. They are just default. So I would specify that the first that we have, the start sensor is the first number is 1. And the subsequent ones, we can only have 3 sensors, right? So let's do that. You don't need to run right away. I'm going to save it. And when I run, it will be using those properties. So let's go back to Steam sensor client here. Okay, so if you didn't specify the args, it would say, it would prompt you to do that. So if I went and just like, if I hadn't done that and I did run as, it would say required arguments not found. But we've already specified. Now let's have a look at that. So again, like the process is there, we create a config where we set the args, set the URI, we set the security claims from the app key. We've already done that. And then we set a name for the client, Steam Sensor Gateway. That's just a few default things. Everything else is similar. Now the scan rate is taken from the third argument. We've taken that, and the start sensor and the number of sensors can be overridden from the argument. We said 1 and 3 for this, and we set the scan rate as 1,000. This loops through all the sensors that we need here for Steam that we're going to do that. And if you notice here, the way it actually assigns is by calling it Steam Sensor ID. So it would be, as the counter changes, it would be binding 1 by 1. So it would be Steam Sensor 1, Steam Sensor something else, Steam Sensor something else, like that. And it's also adding a property change listener for the Steam thing, which means that whenever the property changes, event changes, if temperature limit changes, then write to the console and say temperature limit has been changed. So this event would be received from the cloud, possibly, and then it would be updating here. So that's a very cool thing that can be done in that. Now let's see how this works in parallel. So let's go back. The key items that we need here, if we go back to this, if we go back and let's look at the things that are there. Let's go back to search entities. Sorry, let's go to browse. Let's look at our things. So we've actually got first floor steam sensor, second floor steam sensor, and third floor steam sensor. Now, remember we said the names have to be the same, but these are the 3 sensors we're going to use. Now, if we click on first floor steam sensor, though it's a different name, if you look at that, it has been given an identifier targeting it as SN001, okay? So what's going to happen here is, like, you can see here that the identifier is specified. So SN000 plus 1, so it'll concatenate the sensor ID. SN001 will correspond to our first sensor. So the identifier is actually what's being used on there. Now, if you go back also to look at your manage, and let's go to our, oh, sorry, where am I? Sorry, not manage, you want to go to your monitoring. So under monitoring, if you look at remote things, you'll see the unbound entries. Right now, there's nothing there, but you've got first floor steam sensor, second floor steam sensor, and all that, which are unbound at the moment, and they're unconnected. And if you look here also, you'd see they are unconnected because we've not started up our edge application. Okay. So let's go back to our edge application. Let's see what we can do for creating this. We've specified the properties and we actually run it as because I didn't save the arguments properly, I guess. I didn't save it properly. Okay. So we go to arguments. The first argument is there, and then I'll just say 1001.3. So let's run it using this. I'll just save it in case it will do that. So when we run it now with the arguments, it is connecting. Okay, so we know it's doing something. Now, if we go back to Composer, it says first floor steam sensor is connected. And if we look at, sorry, if we go back to monitoring also, remote things, and if you look at unbound, it's got no unbound there, but we've got a few bound things here. And they are now connected. So first floor steam sensor is connected, second floor steam sensor is connected, and as well as third floor steam sensor is connected. So we are able to bind this like with one line of code, and it's not killing the connection here. Unlike in the previous example, it's keeping it open until we actually decide to clear. So you can see that it's actually running. So we were able to bind things. We were able to multiply, bind multiple things and then start it and maintain the connection. But what does this actually mean? Like, what does it mean that the connection is there? Now, if you go back here, and you go to the properties and alerts, you'll see that the properties are actually refreshing every 1 second. And we're seeing this get there. So it is getting some default values, which it is getting from the edge, and it is uploading it on there. Now, also what you want to do is like, okay, in this case, the servers are already added, but you can also browse remote servers, and we've already added them. So all the functions that we defined on there are already available here. And they've already been added. Otherwise, we can actually add them here. So you can get your services and your properties. If you want to see the properties, it's already been bound here, but you can bind them. When you do manage binding, you would see all these here. So you could do a new item that actually contains all this if we can sync it up with that. If you want, when it's disconnected, I can go and disable that. Okay. So now all the function, I can actually call the service from there. So get steam sensor readings, which was bound there. If I go and execute it, it is actually getting me the table that we created on the edge, but showing it in the cloud. I mean, this is just dummy table, but it did that. it does that. Now, the next thing we want to look at is, let's look at our properties and alerts. Now, right now, if you look at our code, where we did like temperature limit, right? It's doing that, sorry, in our Steam thing Java. So we set a condition for a fault here. Okay, and this is, by the way, where you can see it's how it's populating the values. It just creates 400 plus 40 star random, and that is what's being updated every second and is getting the properties on there. This is the fault status that we're looking at, so it should run when the sensor is a fault. So it checks if the previous thing is executed. And there's not much more here. Okay, so let's play around with our temperature limit as well, right? So the condition that it checks for is if temperature limit right now is 0, so it doesn't do anything. But if the temperature is greater than temperature limit, it reports a fault. It says fault status is true. So let's try to get this happening. Again, this is happening on the edge, and we are triggering it from the client. So if we do this, if I go here and I set the temperature limit, let's say to a pretty low value, to 200, which we know our value is going to be greater than because it's 400. And if I click on this, let's refresh the values there. You can see our fault status is checked on, and our temperature limit there is being exceeded. So the fault status will keep staying there, and it'll keep doing stuff based on that, right? Now, the other interesting thing you should note is that by doing that, though we've set it on the cloud, it is also giving us an error message there. So, okay. Kind of runs away because it's still working on there. I'm just going to stop it and rerun it later. Let's go to the top of the console so I can find it from there. So we've given a, have I spelled it wrong, or temperature rather? We need to search from the top. Oh, no, have I? Oh, because it's terminated. Okay. Anyhow, let me just run this again. So I'm just going to set it to a non-threatening value, which is like it'll be within the range. You should get a message saying temperature. So temperature limit, you can see there. It says temperature limit on steam sensor has been changed to 200 degrees. Has been changed to 700 degrees, and then I changed it back. So all the temperature changes I made on the client, remember that was a non-read-only property, so I could edit it here, are being propagated back. So they can be caught there as well. Now we're going to do another interesting thing with this. Let's, before we move on to the last example that we have, which is file transfer, let's remember we also created a remote event. Now, unlike remote services, where we can browse remote services, and in properties, we can manage the bindings to see the properties that are coming from the edge. Remote events don't directly actually give us something. We need to create them manually ourselves. So what we need to do is we need to, it exists in the virtual thing, but we need to create it here. So I'm going to create that Steam sensor fault event, right? I'm going to create, sorry, it's called a Steam sensor fault, and it's going to be a remote object. The data shape, remember, it only has a message. So I'm just going to give it a, I'm just going to give it a generic alert event because it only has an error message, but you can send other properties using the payload there. You could send, like, for example, the temperature value, the other values that cause it. But in our case, there's just a simple message that says it has that. So I'm just going to create that. Now, this is a remote item that is there. What I want to do is I want to trigger this. Right? And I want to respond. So like normally with events, under events, I can go and say, I'm going to create a subscription to that event. So first thing I need to do is say enabled, and I'm going to call it, say, fault event, right? And this should respond to an event, which is my custom event, that is Steam Sensor fault. And I'm going to write a little bit of JavaScript so that whenever this fault happens, I just want to set, I want to set the temperature limit. So me is just referring to the same item. So whenever there's a fault, because the temperature limit has been set to some ridiculous value like 200, I want to set it back to something more sensible like 700. So notice the sequence events that happens here. The edge will trigger an event, that event will propagate, and this subscription will react to that event and perform some action on the property based on that. So I'm just going to do that, save and continue, done. So the event is there. Now, if I go back to my properties, so right now it's not going to do anything, but if I go there and I edit and I set my value to say 250, which we know it's going to exceed. Now, initially, when I refresh, it will give me the error. It will say fault status is true, right? But if I refresh again, okay, right now it's not triggering the event. I think I've made some error in this. So the data shape, oh, I didn't. I need to make sure it is alert, remote. The remote event name I should give there. It is also Steam Sensor fault. So it has to match the same thing there. We do save. We go back to the subscription. Just make sure that everything is active. So you got a fault event. Everything is running here. I go back to properties and alerts. I go to my temperature limit. Let me set it to 0 first so that it just resets everything. So now if I refresh, my error code is gone. But now if I go and I set it to a value, 250, it will trigger an error. But now in the subsequent one, when I refresh, my event has been caught by my subscription and reverted the value to 700. So you can set up these complex chains where these values are changing based on that. So it's auto-corrected in the sense. Again, like if we go back to the services, so you can see in Eclipse, my process is still running. Another powerful thing is like we've also created, if you look at Steam thing.java, if you look at, there's a shutdown function created that just kills the thread. So shutdown just kills the thread on the edge from there. But because it's been devised as a function here, it is available on the cloud also. So I can go to shutdown, the shutdown service here. And just by executing it, it will kill my thread on here. And there you see. So it killed the thread on here automatically without me actually coming to the edge. So that's quite powerful. So if you look at that, and then you can see, of course, it stops refreshing, and then the properties also stop refreshing. So this is really powerful. And once you have all this data here, like we've done in the past, we can create mashups that show this in a graphical form. And that's the client application that can be used here. Okay, we are running a little bit over, but I'm going to show you one last example that is a little more complicated. Actually, no, we've kind of run out of time. We'll just see like how we can work here. So if you just go to file transfer example, now the file transfer example shows you how you can create virtual directories and you can do a few different things on there. I'll do one thing. I will actually publish this later on because we are running over, but this pretty much concludes what we wanted to show you on the system here. So you've seen how you're able to connect items from the edge directly onto there. So simple thing .java, we did that successfully. We showed you how to connect the connection, to initialize the connection. And then we showed you a simple item that we virtually bound, and we got you directly on that. If you have any questions about this, please do get in touch. I'm going to try to add a few more resources that you can see later on. So let's have a look back. I'm going to go back to my presentation. That covers it for that. Thank you all for joining that. If, like I said, if you have any questions regarding this, feel free to contact us and we will definitely get in touch. Our next workshop is going to be at the end of March, well, close to the end of March, on 28th March. That's another Sunday, the same time, where we'll be working more on the server side. We'll show you how to work with mashups and create a customizable web dashboard for IoT. I will be going on posting resources about the current session, but you can definitely sign up for this. You have to sign up again. We'll be sharing the link in the next few weeks for this, and you can sign up on there. And that's about it. Thank you all. I'm just going to stop sharing my screen. Let's come back to, so that covers it for our subject this day. Feel free to send questions across to me. You can contact us at iot@theassembly.ae if you have any specific questions. But I'd encourage you to try out with the Java SDK. And it doesn't only have to be on a computer. You could implement this on a Raspberry Pi. You could install Java on a Raspberry Pi and run it, or on any smart device that you want. You could try it on your phone. You could use the Android SDK if you prefer, or the Java SDK, and you could deploy on your phone. So you can see how you can synchronize all the different things that you can do. So do get in touch, and we'll definitely be in touch with you regarding our next workshop. Thank you all for attending. Have a great day, and we will catch you next time. Bye, everyone.